Good day, everyone. Let's continue with our first lesson, the ecological foundation of environmental science. So the ecosystem functions. This is the processes that link the different structural elements together. And if you can recall, the structural elements of an ecosystem includes the abiotic and the biotic factors or components. Aside from that, we can also classify the biotic factor further into the producers, consumers, and decomposers. So the ecosystem function is based on the trophic structure. There are three main functions in the ecosystem: the production, consumption, and decomposition. Now, the real functional opposites in the ecosystem are and decomposition. So why are they called the functional opposites? It's mainly because their function are somewhat opposite or kabaliktaran, no, with each other. When we say production, there is a build-up of organic structures using materials from the non-living environment. So for example, inorganic to organic. So in the process of photosynthesis, green plants or any plants usually make or manufacture their own food with the process of photosynthesis. And therefore, by using the energy from the sun, by using the raw materials such as water and carbon dioxide, plants actually convert them into organic nutrients or compounds that can be readily available to other organisms. So therefore, in production, which photosynthesis is the main function in production, there is a buildup of organic structures. So when we say decomposition, on the other hand, because sabi natin they are functional opposites, when we say decomposition, this is the degradation of organic structures. Meaning if there's degradation, it's a breakdown. There is a breakdown of organic structures. And decomposers thus decomposition so that the complex structure in the environment, complex organic structures, will be broken down and pieces of these nutrients will be returned to the soil, to the air, or even to the water, and so that these may be incorporated once more by the producers in their process of photosynthesis or their production process. And thus, we call production and decomposition the functional opposites. When we say production, it's a build-up. When we say decomposition, there is a degradation or a breakdown. Now, consumption, out of the three, features both of or shares both of the features of the production and decomposition. So in a way that in consumption, there is actually a buildup of organic structure in the body of consumers. Just like, for example, we human beings. When we eat our food, it means we are breaking down our food, right? Mukhaon taog like lettuce or rice or whatever. So when we eat those things, gina-break down na to siya. So we're actually breaking down those foods so that we can get the nutrients out of it. So in a way, we are decomposing our food. We're breaking down our food. But on the other hand, um, after we degrade our food or break down our food, there is a build-up of um, matter in our body. So say for example, mainom tagatas, and then we digest the milk that we drink. So therefore, makuha na to ang calcium sa gatas or like iron, nabay iron ang gatas. So we can get all of these um, nutrients from the gatas, and these nutrients, say the calcium, would be used by our body to build up our our bones for stronger bones. So in ano no, there is the production function inside happening inside of our body because by using these nutrients, there is a buildup of organic structure inside our body. So that is the production component of the consumption. So yeah, as we can read here, there is a build-up of organic structures in the body of the consumer using the materials from food that had been broken down during digestion. So that is what we mean by consumption. It shares the feature of production and decomposition at the same time. Now let's focus first on the production function of the ecosystem. So once again, production is the function responsible for the accumulation of organic structures in the ecosystem. So as what I've mentioned earlier, when green plants or producers does photosynthesis, there is an accumulation of organic structure. There is manufacturing of food, turning inorganic to organic compounds and something like that. So in the production function, we first begin with a free energy, um, specifically the energy from the sun, that is very useful in photosynthesis. So there is the free energy is fixed from some energy source, such as the solar energy for photosynthesis by phototrophs, and from chemical compounds, or what we call chemosynthesis by chemotrophs. So in production, by the way, it's not just green plants who does production or photosynthesis, but we also have specialized bacteria that lived in dark places where sun could not penetrate or could not reach. So in those areas, such as the deepest parts of the ocean or the soil, sa middle of the soil, kanang kumbaga sa ilalom sa soil, sunlight would not be able to reach there. And so there are specialized bacteria nga naga-undergo og chemosynthesis. um, I have mentioned that from our previous video, no, that chemosynthesis and photosynthesis are somewhat, they are the same thing. They are the major process in production. It's just that when we say chemosynthesis, there is an absence of sunlight. But the process is actually still the same. These bacteria also manufacture or create their own food. It's just that they don't use the solar energy, but instead they use chemical energy to do that thing. So um, going back to the production process, so there is a free energy that is fixed, and in photosynthesis specifically, the raw materials that is used is carbon dioxide and water. So please remember those things. In photosynthesis, the plants use or producers use carbon dioxide and water, and they use the energy from the sun to, transform these raw materials into usable forms or organic compounds, nutrients, for their own consumption and for the other consumers. So carbon dioxide and water, these are raw materials used in the first step of production. And after free energy is fixed, these raw materials are transformed into energy-rich glucose materials, resulting to the evolution of oxygen gas. So we have here the chemical reactions, or the equation that summarizes the chemical reactions plants and many other photosynthetic organisms use to make ATP and organic molecules for growth and reproduction. So as you can see in the equation, we have sunlight. Plants do need the energy from the sun. So sunlight plus six molecules of, we call them molecule, I guess. We have six carbon dioxide plus six water or molecules of water, and that would lead, or that would produce this one, C6H12O2O6, stands for glucose. So this is kumbaga the uh, chemical formula whatsoever of glucose, no? So this stands for glucose. Plus O2 is oxygen. So the product of photosynthesis for each for per 6 carbon dioxide plus 6 water, that would produce 1 glucose and 6 oxygen. So don't forget this equation, as this is the equation for photosynthesis. So photosynthesis is the major process in the production function of the ecosystem. But Of course, we also consider chemosynthesis as one function since they are almost the same thing, no? So that's it. That's the production function in the ecosystem. Now, consumption is the function which balances the opposites, production and decomposition. It also acts as regulator, careful that production would not be too much and decomposition too little, or vice versa. So the main process in consumption is very common to us. It's called respiration. Specifically, it's cellular respiration. So in the consumption, the chemical process in consumption involves the digestion of ingested food material with the aid of digestive enzymes. And these digestive enzymes simplify, rearrange, and absorb the food material such that animal protoplasm would be synthesized. So that is the production part. The first part, which is the decomposition part of consumption, is, you know, the digestion of the ingested food with our digestive enzymes. Now, the building of protoplasm, or any um, cells, muscles, bones, or whatever it is in our body, that is the production part of the consumption. Now, um, organisms in the ecosystem perform different functions. All have the common ability to break down food so that energy can be released for use. So in consumption, the main process here is to release energy, or to use energy in that sense. So the process of unleashing bound energy for utilization with the aid of oxygen is called respiration, or the cellular respiration. So with the aid of enzymes and oxidants, the chemical bonds in glucose, which is in our food, snap to give off energy. So the summary chemical reaction for respiration is presented below. So in consumption, as I've told you, the main process is respiration. So in respiration, the materials that you need for respiration is of course the glucose. This one right here, the C6H12O6, that stands for glucose. We have one molecule of glucose plus 6 oxygen plus 6 water, and that would produce 6 carbon dioxide plus 12 waters plus ATP, or energy. When we say ATP, this stands for adenosine triphosphate. I guess that's triphosphate. I'll just correct that one to you know, but it's adenosine triphosphate, I guess. So I'll give you the correct um, spelling for that one. But ATP is like the energy currency. Kumbaga, this is a kind of compound that has that always brings with it energy, or it's a source of energy. So ATP, or the total energy released in the respiration process is utilized to fuel all essential functions in the organism, or even in our bodies, because we are organisms. So the energy released is utilized to fuel protoplasm building, reproduction, locomotion, even photosynthesis, ingestion, sorption, and so on and so forth. All of the bodily functions that we have. So that actually undergoes or needs the process of respiration. Now, respiration can be classified into two. We have what we call aerobic respiration. The spelling is AEROBIC, aerobic respiration. That's a type of cellular respiration that involves the use of oxygen. Okay, that's why it's called aerobic. Now, we also have what we call anaerobic respiration. It spells AEROBIC. Anaerobic respiration is the type of cellular respiration that does not involve oxygen. So in places that there is limited oxygen, such as the deepest parts of the ocean or the soil, uh, if low na ang concentration ng oxygen in those parts, there is anaerobic bacteria that carry out the respiration process or the cellular respiration process. Now in respiration, 'di ba, I've told you that it energy is used in respiration process. Now, if energy is not utilized, any surplus energy na wala nagamit for our locomotion, for any of our bodily functions, this will be dissipated as heat together with carbon dioxide. So meaning ma ano sa tawag ani kanang ma-dispel siya, no, mapagawas siya, ma-excrete siya sa system, sa organism as heat together with carbon dioxide. That's why in respiration, 'di ba, sometimes, or it's commonly called respiration kapag ka nagasingot ta. So kasi that's part of the respiration function of organism. So when we that's first part pala, no, but that's related to it. When magsingot ta, magpagawas ta, di ba, og like water, fluid sa ato ang lawas. So we are actually drinking water and then ginapagawas lang pud nato ang ato ang kumbaga ang atong nainom na water through our body. So magsingot ta or kaya pag mangihi ta, so excrete lang gihapon nato ang water nga ato ang gi-intake. So that's actually part of respiration. Even the function of us breathing out, so exhaling, pag naga-exhale ta, nagapagawas ta og carbon dioxide, right? So we use oxygen, we inhale oxygen for our bodily functions, and then we exhale carbon dioxide. So that is the process of respiration. As you can see in our equation, we have here, kumbaga sa ingredient na part, no, we have here oxygen. So this is what we call this is what we call aerobic respiration. So not the oxygen, not put the water. And what's the product of that? The product includes carbon dioxide and water, as well as our perspiration kanang pag magsingot ta or mag-exhale ta og carbon dioxide. And at the same time, heat is also expelled from our body, any energy that is not used for the process, our bodily functions or bodily processes. So yes, that's consumption. If we eat something, we break down the glucose, the carbohydrates, the whatever nutrient it is in that food, and we we transform those nutrients into other usable forms for our body, for our locomotion, and other bodily functions. So that is consumption. And let's remember that the major process in consumption is what we call cellular respiration. Lastly, we have the decomposition function of the ecosystem. So this is a function responsible for the breakdown of complex structures in the ecosystem. So the process of consumption involves the presence of the substrate. So there is two materials that we need for decomposition to happen. The first one is a substrate. When we say substrate, these are any materials such as fallen leaves, twigs, logs, animal matter, feces, grass, etc. No, all um, dead organic matter is considered a substrate. Of course, you cannot decomposition cannot happen if there is no material na kailangan i-decompose, and that's why we have substrate. The second thing that is needed in decomposition is degradation enzymes. Kailangan ng degradation enzymes so that the substrate might be degraded or decomposed. And remember our topic on decomposers, the different types of decomposers. We have the saprophytes or saprotrophs, which actually secretes degradation enzyme externally. So magpagawa sila sa ilang body, ilang lataon ang substrate. Now another thing is, or another one is the detritivores or detrivores, wherein kailangan nila i-ingest and sa tiyan sila magpagawas of digestive enzymes. So that's decomposition. You need a substrate and then you need also a degradation enzyme. So these enzymes reduce the complex organic structures into simpler degradation byproducts. And I have also mentioned from our previous video that only a portion of degradation byproducts are absorbed as food by the decomposer organisms. Most of these nutrients, if not leached, meaning when we say leached, kumbaga, dili manuksok sa soil ba, like manuksok sa soil tapos padulong gid siya sa pinakailalom, it's already leached, so dili siya magamit sa organism. So if it's not leached, those nutrients, they find their way back to the plants and again become incorporated in the living protoplasm, meaning these nutrients or products of decomposition is mobalik lang po siya sa producers to continue the cycle of life. So producers will once again use these nutrients, build up again organic structures, and they get eaten by different consumers. And if all of them die, plants, consumers, if they die, they decompose once more, and the organic structure is broken down again in the process of decomposition. So it's just a cycle of life. No? So all of these functions in the ecosystem are interconnected with each other. So additional information: in a terrestrial ecosystem, aerobic decomposers such as fungi are responsible for most wood decomposition. So kapag ka mga dead logs, mga woods, fungi ang decomposers for those matter. While aerobic decomposers such as bacteria are responsible for succulent plants and animals. So usually pag mga dead plants, dead animals, mga bacteria ang nag-act upon them. But uh, of course, nagyapon tayo detritivores, no? Yung sinasabi ko na type of decomposers na kauno nila daan. So they can also uh, um, process in, or they can do their decomposition process in woods at the same time in dead animals or plants. So in aquatic ecosystem, it harbors mostly anaerobic decomposers because such habitat are limiting to oxygen. So parang uh, res, uh, sa respiration lang po no, na naatay mga anaerobic type of respiration and aerobic respiration. Naputay ginatawag na aerobic decomposers wherein kailangan nila og um, oxygen to do their decomposition function. And anaerobic decomposers naman kapag there's no oxygen to carry out the decomposition function. So again, in decomposition, you need substrate and you need degradation enzyme for the decomposition function to happen. Now let's move on to energy flow in ecosystem, wherein we will learn about how energy or matter is transferred from one organism to another, or from producers to uh, primary consumer, secondary consumer, and so on. The law of thermodynamics govern energy processes in biological systems. So the most fundamental law governing our planet's finite resources states that matter can neither be created nor destroyed. It can only be reshaped or transformed. So meaning all of the energy is actually constant in our environment. One cannot create new ones. One cannot also destroy this energy, no. But it can only be reshaped or transformed. And in converting matter from one form to another, energy is needed. So we have here two laws of thermodynamics that govern energy processes in the ecosystem. The first one is the law of conservation of energy, which states that the total amount of energy in all its forms remains constant. Thus, energy is neither created nor destroyed, it can only be transformed. So, once again, say for example, we have solar energy that is, or if we transform that one into another form of energy like chemical energy or mechanical energy and or and so on, they act solar. energy is not actually being destroyed or created, no, in that sense. It's only transformed into another form of energy. Now let's move on to the second law of thermodynamics, which is the law of degradation of energy quality. So when we say degradation of quality, meaning there is a good quality, and then it gets, once it transforms, it gets degraded to a lower quality, no, or to a lesser good quality. So this states that every time energy is transformed, it tends to go from a more organized and concentrated form to a less organized or more dispersed form. Thus energy transfers are never 100% efficient. So it means that, say for example, there is a plant, and then ang plant, it contains matter and energy, or nutrient and energy within it, diba? So pagkaunon ang plant sa um, goat, ma-transfer ang energy and matter sa goat. But then again, since the law of degradation of energy said na energy transfer is never 100% efficient, meaning dili 100% ang makuha nga energy sa goat gikan sa plant. Only a portion of it is nakukuha ng goat, or nata-transfer sa goat. Some of them, if dili niya makuha, dili niya magamit, diba, it's dissipated as heat. It's expelled uh, back to the system as heat. So what we are saying here in these two laws right here, the first law, it's the conservation of energy. Like for example, in photosynthesis, solar energy is converted, diba, to chemical energy. So wala yung na-create, wala po yung na-destroy. In um, During photosynthesis, conversion of solar to chemical energy will not be equal unless heat losses are accounted for. And thus, that actually says something about the degradation of energy quality, no, na um, the transfer is not 100% efficient, but it will become 100%. Kumbaga, it will be equal if we account the heat losses. Kay katong ingon ako kaganina in respiration, if energy is not um, used, this is dissipated as heat, so expelled back to the system as heat, as an unusable na heat. In an ecosystem, energy in the form of energy-rich molecules stored by producers is taken in or eaten by series of consumers. So ultimately, any energy fixed by producers or accumulated by consumers and not used by them is released by decomposers. So this feeding relationship is either a food chain or a food web, and this illustrates how energy and matter is being transferred from one organism to another organism. Now, in food chain, I guess this is familiar to all of us. This is illustrated as you can see on your screens right now. Food chain refers to the transfer of food energy from the source, which are usually the plants, the producers, through a series of organisms in a process of sequential, meaning sunod-sunod, or repeated eating and being eaten. So each time one organism eats another in the food chain, energy is transferred. So, katong example na to nga, ang grass will store within its body energy-bound, energy-rich molecules as well as nutrients. So, kapag kakaunan siya sa grasshopper, ma-transfer ang energy molecules into the grasshopper. And since na-transfer na siya sa grasshopper, pagkauna na po ang grasshopper sa bird, matransfer na po ang matter and energy sa bird, and then so on and so forth, hantod maabot sa snakes, and then the apex predator, which is the owl in this sense. Now, if all of these kunyari, mga matay ni sila, so there will be stored energy molecules and nutrients within their body, diba? So these stored energy molecules and nutrients will be broken down by the decomposers and para ibalik na pod sa ecosystem so that the cycle will continue. So in food chain, the transfer of movement or movement of energy is in one direction only. So usually from plants to a series of animals eating each other. And man is ultimately at the highest trophic level. So we can consider ourselves as apex predators because naturally wala gid tay mga natural predators. We are kumbaga at the top of the trophic structure, of the trophic level. By the way, we have mentioned that in a food chain, every time an organism eats, there is a transfer of energy, right? So for every transfer of energy, 90% or like 80 to 90% of the energy is actually dissipated as heat. So hindi talaga siya nagagamit, no? So it's just only 10% of the original energy is usable by the next organism. And in food chain, we have two types. We have the grazing food chain, which starts from the green plant base from a green plant base from which the chain goes to grazing herbivores and then carnivores. And another one is the detritus food chain. From the term itself, detritus. When we say detritus, it pertains to dead. So the food chain goes from dead organic matter into microorganisms and then to detritivores and their predators. So these are the two types of food chain, the grazing food chain and the detritus food chain. If there are a lot of food chains, we call them the food web. Like, collectively, it's a food web. So it refers to the interconnected or interlocking relationships among various food chains in an ecosystem, which is represented by the diagram on your screens. So in a food web, an organism may feed on several members of the web, just like, for example, here we have different um, primary consumers. We have rabbit, mouse, and then grasshoppers that preys on our producers or the grasses. And these, for example, the rabbit, daghan og mukhaon sa iyaha. We have the fox, we have the hawk. So yeah, in this food web, duha ka buok. The mouse, on the other hand, it has three predators. We have the fox, the hawk, and then the owl, and the grasshopper has the frog and the birds as its predator, and the frog has the owl and the snakes as its predator. And ultimately, the rabbit, the owl, or the rabbit, the mouse, and the snakes are eaten by the hawk. So this is a food web. Food web, if it refers or if it presents an interconnected, interlocking relationship among various food chains. Now we also have what we call the ecological pyramids, and these are pyramids that is used to illustrate the distribution of matter and energy within an ecosystem. So this can we can use any of the three measures of energy flow, which is the energy, the biomass, and the numbers represented in pyramids, so that we can actually picture out how energy and matter is being transferred from one organism to another, from one trophic level to higher levels in the trophic structure. Now, the pyramid representation constitutes the overall structure of dependency among the biotic and the living elements in an ecosystem. Thus, we have here pyramid of energy, the pyramid of biomass, and the pyramid of numbers, which are all types of ecological pyramids representing how energy and matter flow in an ecosystem. First is the pyramid of energy. So this type of pyramid shows the decreasing amount of energy in each trophic level. So this is what I have mentioned earlier, so a while ago, no, na in every energy transfer, it's not it's not 100% efficient. So dili 100% yun ang makuha sa next na mukaon sa, let's say sa from producers. Ang primary consumer dili 100% iyang makuha ng energy, and then the secondary consumer dili pod 100% iyang makuha from the primary consumer, and so on and so forth. So we can see in the illustration, say for example, natay 100% energy coming from the primary producer, from the producers. So some of the energy is dissipated as heat, di ba? Pag dili magamit in our metabolic processes and other bodily functions. Pagkaunon sa primary consumers ang ato ang producers, energy is lost as heat. Excuse me. So, 10% lang ang kanilang makuha from producers. 90% will be lost as heat. And then, from the primary consumers, ang ilang secondary consumers, 1% na lang ang makuha. Kasi since 10% of, excuse me, 10% of 10 is 1 na lang, di ba? So, 90% will be also dissipated or lost as heat, and then so on and so forth. So, ang third level consumer, 0.1% na lang ilahang energy na magamit. So, some of these energy are used for metabolism or dissipated as heat. Kumbaga, ma-expel lang siya as heat. Now, in the biomass, pyramid of biomass, this represents the total weight of living matter at each trophic level. So, when we say biomass is the total weight, no? Kani siya, total weight ni siya sa tanang living matter in each trophic level. And so, ang biomass, it represents the total dry weight of living material available at each trophic level. So, makita po nato dire na as the available biomass actually decreases as the pyramid goes up. So, meaning, kailangan nga mas daghan gyud ang organisms at the bottom, kumbaga at the first level of trophic structure or trophic level para makasurvive ang mga organisms on top of them. So say for example, this one sa 809 grams per square meter, 37 grams per square meter lang dapat ang primary consumers na mag-consume ani. So, the number is not constant, by the way, ha. This is just a representation. And on top of them, dapat mas gamay. Sa secondary consumers, dapat 11 grams na lang per square meter ang pwede mukaon sa kaning primary consumers nga naata. So, again, it represents that those at the very bottom is very important for the continued life existence of those at the top. No? So the third one, we have the pyramid of numbers. Mainly, this represents the actual number of organisms consumed by the level above it. So, for example, if natin 500,000 primary producers, kamay lang dapat ang primary consumer, dapat na lang tayo mga 200,000, no, as represented here in the pyramid of numbers. So again, the reason for that is that dili pwede nga mas daghan ang mga naa sa taas kontra atong mga naa sa ubos, because there will be competition of resources, and kumbaga the survival of the fittest will kick in, no. Kapag kadaghan ra kaayo ang mga consumers, kulangan na ang atuang food. So kulangan na ang katong mga producers, and if kulangan ang food, some of us will starve, some organisms will survive, some of organisms will die. So it's not it will disrupt the balance. As what I've mentioned, the very existence of those at the top of the pyramid depends largely on the capacity of those below to maintain their existence in a way that adequately supplies the needs of those on top through time. So the sustainability of the pyramid rests on the continuing presence and efficiency of those at the bottom level. So therefore, very important gid kaayo no nga, mas daghan, mas mag-thrive ang, the producers, those at the very basal level, so that mag-continue mag-exist ang mga naa sa taas. So the concepts of food chain, food web, and energy pyramid are important to consider in monitoring the effects and activities in ecosystems. So any activity not naturally or originally part of the ecosystem would certainly cause disruptions in interactions related to taking in food. And thus, um, we reiterate that any unnatural activity in an ecosystem, as we say, ecosystem is one functioning unit, right? So any disruption in the ecosystem, maski gamay lang kayo na disruption, it will actually affect all of the units, the small units or members of that ecosystem. So basically, that's it. That's the functions of the ecosystem, and as well as how energy flows in the ecosystem. And that ends our lesson for the ecological foundations of ecosystem. Thank you for watching this lecture, and see you on our next lecture.